It's very well known that teaching the concepts behind the invert and multiply approach to fraction division is very difficult. And so we set about to design an activity on Fogstone Isle that would help make intuitively clear why invert and multiply works. The game is, we have a field here, and these animals are called Rollerdillos, and they tend to roll away. But we want to build a pen that will enclose them so they stay in our field. So here's an example of a complete pen that I built. The way it works is when a Rollardillo is starting to roll away, you want to build a fence that will block it. And so you'll draw a fence, and initially for all of the problems, the fences are size 1, and when you want to build the fence, you get a shipment of panels. Initially, all of the panels are unit fraction sizes. So the fences represent the dividend of quotative division problems, and the panels represent the divisors of the problem. So here, I wanted to build a size 1 fence. I got half-size panels, and so I moved them in to build my fence, and I can fit 2 half-size panels in a size 1 fence. Moving on to some more problems. Now I'm building a size 1 fence, and I got a shipment of 1/4 size panels. So I moved them in, and it took 4 1/4 size panels to build the size 1 fence. So this is after we solve a number of problems like this with dividends of 1, panel sizes, or divisors of unit fraction size, it becomes more and more clear that the denominator is acting like a numerator. It's telling us the number of panels that will fit in a whole fence. Now I move on to fences of other sizes, still whole numbers, but the panels are still unit fraction sizes. So now I want to build a size 2 fence. I got a shipment of 1/4 size panels. I can fit 8 of them in, 4 for each unit size of the fence. So now the 2 is getting multiplied by the 4, the number that fit in each one, in order to give me the total number of panels that will fit. So here again, that denominator is really starting to act like a numerator, an enumeration, a number of panels that fit. So again, in this case, I have a size 2 fence. I got a shipment of 1/3 size panels. Now, let's say I get another shipment of panels. Again, it's a size 2 fence, and these are 2/3 size panels. Well, how many can I fit? This is the first time that I've gotten non-unit fractions for panel sizes. This is twice as big as the 1/3 size panels. If the panels are twice as big, I can only fit half as many in, because each one takes up twice the space. So visually and symbolically, we're presenting that same concept. So what we're seeing happen is that numerator is becoming a divisor. The bigger the numerator, the bigger the panel, so proportionately, that many fewer panels is what it takes to build the fence. So working on many problems of that type, the intuition becomes clear of why the denominator becomes a numerator, the numerator becomes a denominator, and then I can solve my problem.